today we're looking at notes 11.3, discontinuity. So when you have a discontinuous graph, it's broken, split, or you have to pick up your pencil and start again to finish the graph. For example, asymptotes and holes create a discontinuous graph. So these right here are the ways that you find horizontal, vertical, asymptotes, and holes in a rational or reciprocal equation. So go ahead and pause the video, write these down. Okay, so using what you just wrote down, we are going to find all the points of discontinuity for each of these examples. So looking at example number 1, first we're going to find the horizontal asymptotes. So like what you wrote down, you'll recall that when finding horizontal asymptotes, numerator and denominator need to be in standard form. You need to look at the degrees, and that will tell you what the asymptotes are. So both numerator and denominator are in standard form, and because on this one the top is smaller, the top is 1, the bottom is 2, then my horizontal asymptote is y equals 0. Okay, now moving on to vertical asymptote. For my vertical asymptote, I need to have both numerator and denominator fully factored. So for this guy, the top is already factored, x plus 3, can't do anything more with that. In the bottom, I would be looking for numbers that multiply to negative 12, but add to negative 1. So that would be x minus 4, x plus 3. So after I've factored it, what I need to look at is all zeros of the denominator that don't cancel. So looking at the denominator, I have 2 zeros, but the x plus 3's are going to cancel. That's actually going to be my whole. Remember, occur at all zeros that cancel. So for my whole, I'm going to have x equals negative 3. That's my 0 that cancels. And then for my vertical asymptote, the only one that didn't cancel would be x equals positive 4. So that one there. All right, let's move on to example number 2. So for example number 2, my horizontal asymptote would be, well, let's look. We're looking at the degrees because they're both in standard form. So the degrees are the same. When you look back and the degrees are the same, you take the coefficients of the numerator and divide it by the coefficient of the denominator. So on this one, the lead coefficient of numerator is 3, divided by lead coefficient of denominator, that's 4, so it's just 3/4. It doesn't reduce any further. That is my horizontal asymptote. My vertical asymptote and holes need to be found after I factor. So looking at these, they both have a GCF. The top has a GCF of 3x, and then what's left inside would be x plus 2. And then over, this one has a GCF of 4x, and that would be x plus 2. So looking at what cancels first, the plus 2's both cancel, so that means I'd have a whole at x equals negative 2, but then you should also notice that my x's would also cancel. So that means I'll also have a whole at 0, okay? Since there's no other factors that are left, I've just got 4, 0, 4, which does not create a 0 in the denominator. Therefore, I'm going to have no vertical asymptotes for this one, so none. Okay. On example number 3, okay, they are both in standard form, both the numerator and the denominator, and looking at this one, my numerator degree is bigger than my denominator degree, so when the top is bigger, I have no horizontal asymptote, so none on that guy. Now in order to find vertical and holes, I need to factor top and bottom. On this one, there's really nothing I can do with 4x to the 4th, so I'm just going to leave it. On this, I'm going to have x as a GCF, and then x squared minus 9. Hopefully you look at that and say, oh, I can go further, because that is a difference of squares. So that's going to give me x plus 3, x minus 3. It's kind of lopsided here, but that's all right. So for my wholes, I would see things that cancel, and hopefully, even though it's kind of tricky to see, you see that an x on top will cancel with an x on bottom. That'll become x to the third and cancel with the bottom here. So my whole would be at x equals 0. That's where I have a whole. But for my vertical asymptotes on these, since neither of those cancel, both of those are going to be vertical asymptotes. So I have a vertical asymptote at x equals negative 3, and I have a vertical asymptote at x equals positive 3. Isn't this just such cool stuff? I love it. All right, so moving on to example number 4. Sometimes you'll see a problem that's given to you in a prefactored form. So to find horizontal asymptotes, you kind of have to go backwards. Even though you're like, oh, I don't want to have to do this, you kind of do. So it's really not necessary to multiply the whole thing out, as long as you can see when I FOIL this, that's going to give me 15x squared, and the inner and the outer are both just going to be x's. So x squared so far is my highest degree. And then if I multiply that times that, that's not going to give me any x's, so dot, 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 dot. That's my highest exponent on top. And on bottom, same goes. If I were to multiply these back together, I'd get x squared, and then the inner would be a 2x. The outer would be a negative 2x, so none of those have a higher degree. That's my highest degree. And remember, all you care about for horizontal asymptotes are the highest degree. So looking at this, the degrees are 2 and 2. So when the degrees are the same, I take lead coefficients. So that's going to give me y equals 15 over 1, which is just 15. So there's my horizontal asymptote. So it's real nice for vertical asymptotes and wholes because it's already factored. And you notice that no factors on top cancel with no factors on bottom. So there are no wholes, none. And then my vertical asymptotes are going to be at x equals negative 2 and x equals positive 2 because the 2 zeros in the denominator. All right, moving right along, I have a couple more examples for us. Fun stuff here. So, example number 5. This one is not prefactored, but it is in standard form. So on this one, my numerator degree is less than my denominator degree. Top is smaller than bottom. So that means I'm going to have a horizontal asymptote at y equals 0. And then in order to factor this, you need to think about this. 7x is not factorable. X plus 5 is actually also not factorable because if you think, there's no number in the world, well, none that are real, that multiply to 5 but add to 0. Okay, there's no numbers that multiply to 5 and add to 0. Okay, so on this one it's not factorable, so that means nothing cancels on top with on bottom, so no wholes. And on this one it's also quite strange because there are no vertical asymptotes. Why are there no vertical asymptotes? There's no value of x here that I can plug in that's going to give me a 0 in the denominator. No real one, because anything squared is always going to be positive. So when I add a positive to another positive, it's just getting more positive. So there's no way for this bottom to equal 0, so therefore there's no vertical asymptote. Okay, pretty neat stuff. Moving on to number 6, it is prefactored. So you need to kind of think about if you were to multiply it back together, you'd get x squared on top, dot, 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 and you'd get x squared on bottom, dot, 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 dot. Your degrees are the same, so therefore lead coefficients your horizontal asymptote is y equals 1. Your holes, excuse me, you would think would be at -5, but what happens is, even though that cancels, you have a vertical asymptote at -5. So because there's an asymptote there, because of this 0, it actually ends up being that there's no hole. There's no hole because there's already an asymptote there. So it's kind of a special situation for this one. Okay? No hole because there's already an asymptote. Excuse me, I had something in my throat. All right, number 7, again, prefactored. So if you were to multiply this all back together, on top, hopefully you can see that you would have 4x squared when you multiply, FOIL it, and then contribute with the 4. And then here on bottom, you would have 2x. So my top degree is bigger than my bottom. So that means for horizontal asymptotes that I would have none. Okay, because I have the x plus 3's canceling, that means my hole is going to be at x equals -3. Okay, and on this one, because I have nothing else left on bottom that creates a 0, I'm going to have no vertical asymptotes, none on this one. All right, so on this one, I kind of want you to try it on your own. What I hope that you'll notice is on top, it's not in standard form. So to find the horizontal asymptote, you're going to have to put it in standard form. And then to find vertical asymptotes and holes, you're going to have to factor. And with this one, I really want you to try, instead of using box, I want you to try using guess and check, because this should be an easy one, because you know that the only way to multiply together to get 2x squared is if one's 2x and one's x. And the only way to multiply to get 7 is 7 and 1. One of them has to be negative. So play with that, see what you get, and try this one out for me.